We did transformations of functions. You know that there's, the sort of the 4 different values you can put in there, and they cause 4 different things to happen. Right? The number at the beginning changes it vertically expands it or compresses it. We're saying we're changing the amplitude. If you make it negative, it actually reflects it as well. So instead of being what we might call a sine curve, we call it a negative sine curve. Okay? The amplitude changes. Amplitude's the distance from the center to the top, or center to the bottom, one of the maximums or minimums. The second value, B, is the one we're going to look at in this tutorial, is the one that changes the period of the thing. Okay, the period is the length of one complete cycle. If you put a number in there, that changes the period. We're not going to look at when that number is negative, because you can see what happens. If you make that negative, it actually kind of does a horizontal reflection, but we're not going to look at horizontal reflections of this. Although you could, I guess. There's no reason why you can't. The other two, oops, we should put that back to 1. The other two are going to change they're going to be translations. Okay, this C value changes, moves it horizontally, horizontal translation. Okay, that's called the phase shift. Shifting the phase, starting in a different place. And the last one here is vertical displacement, displacing the thing vertically. Okay, starting higher or lower. So the first tutorial looked at all of those except for B, except for the period change. If you want to kind of start to form a rule for yourself here, think about what that value does. Okay, if we're looking at changing the period here. This stuff I'm assuming you remember, transformation stuff, you can work with that yourself. Investigating changes as you change the value of B here. I'm not going to go through and do this for you, but I think you should be able to do that on your own, and you're going to learn it better than me just telling you here. We know that if you change this, I'm sure you can predict that it's going to change the period. It's going to compress it or expand it horizontally. It'd be good if you just created a graph that showed a few different ones here. You could graph your normal sine curve on here, and then you could graph, say in one color, y equals sine x, or y equals cos x. You could use all the same one if you want. Then you could graph, say, y equals sine of, pick easy numbers, 2x. You can put the brackets there if it helps you. You could graph y equals sine of, a half x, 0.5x. Think about how it would change the graph. Okay, and then you can think about how you can get the period from that. I would put one other one on there that is going to have either be really compressed or really expanded. Put 1 or 2 other ones on there for yourself, where you have it really compressed or really expanded. Right? If you have to look at one cycle of the pattern. If this is one cycle of the, what did I do wrong there? Where should it go? If it's sine, it starts there. Yeah, it should end at 2 pi here, right? If you're trying to plan out what this looks like, I would put those kind of points for reference. And then even though you have the whole graph there, I'm just going to show you with this one piece of the graph. You can compress it to there, right? All the points move. Okay, does that make sense? If that's sine of x, what's that going to be? If I compress it by a factor of, that's sine of 2x, right? Sine of 2x, because if you put a number bigger than 1 in there, it compresses it, makes it smaller. What about if it was like this? What would that be? Sine of 4x, right? I mean, it's not the whole graph because I've only got a piece of it, but what would this be? Sine of 8x, right? The number you put in there compresses or expands it. If this is what I'm saying, draw something like, sine of 8x or something like that. If you have sine of 8x, How many of these little pieces would fit into the usual period? 8, right? The usual period was this much. If I compress it down to that, there'd be 8 of those in there, right? This number here is like how many cycles there are in 2 pi. Once you've drawn some and figured that out. If you make this longer, right? If you make it longer than usual, so that's the usual, right? 2 pi. If I stretch it out to there, what's that going to be? What's it going to be? Sine of half. Yeah, sine of a half, because I've expanded it by a factor of 2, so this number is smaller than 1. If you've expanded it by 2, you got a half in there. Works the opposite of what you expect, just like when we did transformations. As soon as you start combining it with other transformations, that's where maybe it gets difficult, right? Like if you compress it that way and then shift it over to here and then shift it down, expand it vertically and stuff like that, that's harder to see. To think about the period, all you need to do is look at where one point in the cycle and the next point. When you're graphing them, of course, they're going to look like this, and it's going to be harder to see because you're going to have all the rest of it there, right? But just look at one piece of the pattern when you're working with these things. All right. There's not much other than that for me to kind of directly teach you. The rest is just going through and learning it, right? You're not going to learn it. You're not going to learn it by me going and doing 1,000 questions on here. You're going to learn it by getting the concept. That's the concept, right? When you change sine x to sine of bx, this affects the period. It compresses or expands it. If you want to write some equations for some of these graphs, you got to pick some points on here and look, right? There's a point. There's the same point in the pattern. Look at how long that is. Look at what other changes have happened. What's the amplitude? Is it vertically shifted? Is it horizontally shifted? Phase shift? And write the equations that way. And then we're doing checking your understanding. There's 2 parts to this one because the other part, and we're going to look at this after lunch, the other part is changing to so that the period is a rational number. Like, so you can have a period of 5 rather than a period of 2 pi or pi or something like that. But that's for you to do after. I want you to kind of get done the learning for this tutorial before you go for lunch. Okay? We can't kind of always think we're going to do it later, which is, I think, sort of the mentality. We sit and chat and horse around and don't get a lot done thinking you're going to do it later. There is no later. Like, if you have 100 hours of class time, but we spend, some of you, I bet, have spent 20 hours just chatting and socializing. Really, right? At this point, we've done about half of them. Some of you, I really think that, like, if you added it all up, 10 minutes here, 15, 20 there, I bet you've spent, maybe not quite 20, but you've spent a lot of it chatting away. If you only have 100 hours of class time to begin with, and you're not spending 100 hours outside of class time, you got to use every minute of this, okay? I don't know what to say. If you have high expectations for yourself, you have to start acting in here the way it takes to get there, okay?